In this video, we are going to discuss number 11, specifically research question number 2. It's a scenario which involves a sports analyst who is trying to determine an estimate of the population mean, mu, and the population variance, sigma squared, and the population standard deviation, sigma. In the previous presentation, we already calculated the population, an estimate for the population mean. So now we are going to calculate an estimate for the population standard deviation. So the research question number 2 says, what is the population average dispersion? Okay, that's just another way of interpreting the population standard deviation. Okay, the dispersion between the values or spread of the differences between them. Okay, and hypothesis, the claim 2 says that the population standard deviation of the completion time of athletic race B is greater than 10 minutes. So we need to see if this is true or not. Therefore, we move on to the collection and organization of data. So the sports analyst collected the data by randomly recording the times of a sample of 90 athletes, which was then organized in the form of a table of intervals. Consequently, the distribution presented below can be used to see if the population mean completion time of athletic race B is significantly greater than 50 minutes, and the population standard deviation or average dispersion completion time of athletic race B is significantly greater than 10 minutes. As we said before, we have already analyzed the estimate for the population mean. So now we are moving on to the estimate of the population standard deviation to see if it is greater than 10 minutes. So here's the data which was collected and grouped up in a table of intervals. Each interval is a group, and you have the frequency of each interval. So as stated in the question, part C, it says to choose a method to determine the sample variance S squared and the sample standard deviation. So the sample variance and the sample standard deviation will serve as an estimate for the population standard deviation. And to do that, we can go to week 6, page 6 to 8. So we are all familiar where to obtain the weekly notes. And we are looking at weekly note 6. Bear in mind, it comes in, or they come in PDF and video format. Okay, so you can look at the video format and it will break it down for you. But let's look at the PDF format. So with 6 measures of dispersion, and this is for grouped data. So you have grouped by frequency, and you have to scroll down. And group by intervals, interval distribution. So to calculate the variance for interval distribution, as the steps say, you have to first find the mean, the sample mean, which of course we did already. And there are 2 methods, method 1, method 2, to calculate the sample variance. So we are going to give an example of method number 1. So you have to subtract each midpoint, which of course we already calculated for the mean, which each midpoint is a data value from the sample mean, and that will be a deviation. You square these deviations, and then you multiply each square deviation by its respective frequency, and then you find the sum of the products obtained in step 4. And then you divide by the sum of the frequency. So the above steps can be summarized in the following formula. Here it is. And to find the sample standard deviation, you square root the variance. And here we have an example, 6.7, demonstrating how this is done. So we are going to apply this now to our scenario. Now, before we move on to the calculation, we are going to be using sigma, which is the international symbol for sum or total. Now, please take note, whenever you are confronted with sigma, complete all operations to the right of sigma before you find the sum. So, in other words, add last as the final thing you do whenever you see sigma. So now we are going to talk about what was written on the board. So here it is written that practice paper B number 11C. So here we are calculating the sample variance S squared and the sample standard deviation S in order to estimate the population standard deviation sigma. So here's the data in the form of groups. Here's the frequencies. The sample size is 90, which is the total frequency. And the data value is X, which is the midpoint of the intervals. So the midpoint of 10 and 20 is 15, 20 and 30 is 25, etc., up to 50 to 60, which is 55. So these midpoints will serve as the data values whose symbol we use as X. So whenever you see X, you've got to say data values. Now, as the formula says, method 1, first you start within the brackets by calculating each deviation, X minus all the data points minus the sample mean. Then you square these deviations and then you multiply by the corresponding frequency. So all of this can be done straight away in your calculator. So in your calculator, just type 10, open bracket, 15 minus 33.3, close bracket squared. Because 33.3 is the sample mean, which of course we calculated already. And verify to see if you are getting 3,348.9. Now do this for each one of them and see if you get in these values, which are called the deviation squared, and the total is 10,250.1. Please verify if this is the actual total. Now this will be the sum of the squared deviations. So now, as the formula says, that will be the numerator. And then we have to divide this value, the sum of the squared deviations, that's the 10,250.1. We have to divide it by the sum of the frequency or the sample size, which is 90. And that will give us the variance, and then you square root the variance to get the sample standard deviation for group data. So as you can see, this is what was done here, and the variance was found to be 114.89, and then this was square rooted to give a sample standard deviation. So the interpretation of such a value can be stated as such. On average, the data values are 10.67 minutes different from each other, or the average spread, if you want to say it that way. Or in other words, the average dispersion is about 10.67 minutes. Okay, and this will serve as the sample standard deviation, 10.67, which will also serve as an estimate for the population standard deviation. Bear in mind, we do not know the actual value of the population standard deviation. In order to do so, you will need to collect data from the entire population, not a sample. Okay, and this can be very costly or impossible. So a sample was taken and an estimate of 10.67 was actually formed. So to conclude this presentation, this is a demonstration of how to find the sample standard deviation for group data using method 1. Now remember, anytime you are looking at a math video, you must have your pen, your pencil, your calculator, your book for you to be participating alongside with the video.